All right, so quick review from yesterday when we talked about vertical asymptotes and holes. We said the step one is just get everything factored. All right, so I put the factorization that we had from yesterday up there already. All right, the first one, what are the domain restrictions? Okay, so positive and negative 1. Can either of those factors be reduced out? No. So what does that leave us with? Is it a vertical asymptote or a hole? Okay, so we have vertical asymptotes at x being 1 and x being negative 1, and no holes. Yes? Okay, looking at the second one, I factored the denominator, so my domain restrictions are, okay, so there we have problems, right, at 3 or negative 3. It's either a vertical asymptote or a hole. We have to decide which. So then I look at my factorization and I say, well, this x minus 3 factor could be reduced out. And my reduced function then would be 1 over x plus 3. Yes? What happens when I'm able to reduce it out? It means it's a hole. So what's the x value that made that x minus 3 0? A 3. So I have a hole at x being 3. Okay. Now, a hole is a point, right? It's just one spot on our graph. So we're actually going to look today at how do we find that location. Okay? And to do that, we go to our simplified version. So we look at this version of our function. We can't put it back into the original one because it was a problem, right? It made it 0. But we can put the 3 into here, and then we'd have 1 divided by 6. So the y-coordinate of my hole would be 1/6. Does that make sense? So you have to find it using that simplified version. And then the one that we couldn't get rid of, this x plus 3, gives us what? Vertical asymptote. So x would be a negative 3? Yes? Okay. Our third one. If we look at our factored form, we have one restriction at what value? At 2. We have a problem at x being 2, right? Is it a hole or a vertical asymptote? Why is it a hole? Because we can cancel it out. That means this reduces to just f of x equals x plus 2. We know we have a hole at x equaling 2. So to find that actual location, we're going to plug a 2 into our simplified version, which gets us a 4. Yes? Okay. Last piece here. Let's go back. Quick review for horizontal asymptotes. What is it we look for? How do we find whether there's a horizontal asymptote? Yeah, we have to analyze the degrees. So for the first one here, the degree on top is smaller or larger? Smaller. Degree here is 1. Bottom degree is 2. So when the top's small, y equals 0. Okay. Second one. Do we have the same situation where the top degree is smaller? Okay. So we have a horizontal asymptote at 0. And for the third one, we don't have one, do we? Okay. Now, what the graph is going to look like when you have a hole, you're going to look at your basic simplified function. All right, so I'm going to look at this version. How would I graph that? Do you remember from yesterday when you graphed 1 over x? Y equals 1 over x? We had the 2 branches in quadrant 1 and 3. Which way have we shifted this? Left 3? Okay, so looking at our vertical asymptote at negative 3, horizontal here at 0, and we said our 2 graphs, which started out in this quadrant, and now we had to shift it left 3. Okay, so it's going to end up over here. Yes? And the one on the bottom would shift and land over here. Agree with that? Now, the graph of that is going to be identical to the graph of the original one with one exception, and that's the hole. the original function has a hole. The simplified version doesn't appear to have a hole. But we have to put that hole in because we're graphing the original function. We said there's a hole at the point 3/16. So right here, there's a little hole. So your branch is actually going to look like this with a little hole and then continue on. Does that make sense? You're not going to encounter a lot of things that have the holes in them. I just want to make sure you're clear on that process. Okay? Last one. How do we graph this? Y equals x plus 2. What is it? It's a line, right? mx plus b. Where am I going to start? Where am I going to start? At 2. Has a slope of 1. All right. So I have a line. Y-intercept is 2. Slope is 1. But there is a hole where? At 2, 4. So this point right here is actually a hole. So my line would be everything but that point. Does that make sense? Okay. All right, moving on to our new stuff. We are basically putting all of this together. Okay? We're also going to talk about those slant asymptotes today. So our first step is to find any vertical asymptotes or holes. In order to do that, we do have to have it factored. All right? So make sure you put it in factored form. If there's anything you can factor, go ahead and do that. In this first example, we're going to do each step as we go here with this graph. Is there anything I can factor here? No? Okay. What domain restrictions do I have? X can't be 1? Okay. So if I were going to state my domain, I would say I have to use everything, excuse me, but 1. So 1 is a problem. Is it a hole or a vertical asymptote? Can I get rid of it? No? There's no x minus 1 factor in the top? All right, so it stays as a vertical asymptote. All right, so I know I have a vertical asymptote at x being 1. Our next step is to look for horizontal asymptotes. So we analyze the degree. All right, so using the degrees, what do we know about the degree of the numerator? Degree of the numerator is 1. Degree of the denominator, 1. When the degrees match, where do we go? Leading coefficients. So in this case, my leading coefficients are 2 over 1. 2 divided by 1 is 2. So I have a horizontal asymptote at y equals 2. The next thing we want to do is start finding some points. And x and y intercepts are good points to use on your graph. All right, so we're going to find those. To find our x and y intercepts, remember we put a 0 in for x and we put a 0 in for y, one at a time. What happens if I put a 0 in for x? I end up with just this part, right? The negative 1 over negative 1. What's negative 1 divided by negative 1? Okay, so I have a y-intercept at 0, 1. Now, x-intercepts look like they're going to be complicated when it's a rational function, because now I'm plugging a 0 in over here for my y. Okay? But I want you to think about something first. I'm going to make it a little more basic equation. If I put a 0 in and I have some fraction on the other side, okay, we won't worry about what the expressions are. We'll just call them a and b. When I go to solve that, I'm going to multiply the b over to the left side. So I'm going to get 0 times b equaling a. But what's 0 times b? 0 times anything is 0, right? So we really are looking at what makes that numerator equal 0. The denominator doesn't matter, because it's always going to get multiplied to that 0 and drop out. Okay? So your x-intercept, might want to make a little note here. X-intercept, find what makes the numerator equals 0. All right, so going back and looking at our expression here, the numerator was 2x minus 1. Okay, so we're looking for when is 2x minus 1 give us a 0. We'd have to add the 1 and divide out the 2. So we are going to cross the x-axis at 1/2. Okay. Next step. Plot at least one point beyond and in between any x-intercepts or vertical asymptotes. You have to have enough points that you know what this shape looks like. And keep in mind that rational functions often have multiple branches to them. Okay, that's why we have all those asymptotes in there to kind of separate the pieces. So based on what I'm seeing here, I'm expecting that I have a branch in this section. Yes? Because I had those two x and y intercepts in that little section. But there's something happening on the other side of that vertical asymptote. Okay? So I have to figure out, am I up here or am I down here? Where's the other branch to this? So we're going to pick a couple points. We don't have to do a ton, but you need a couple on the right side of that vertical asymptote. So since my asymptote's at 1, I'm going to choose 2 and 3. Okay? So I'm going to extend my little table of values here. If I plug a 2 in, what do I get? Putting a 2 in the top. 2 times 2 is 4. 4 minus 1 is 3. Putting a 2 on the bottom. 2 minus 1 is 1. 3 divided by 1. So I have the point 2, 3 on my graph. If I put a 3 in for x, 2 times 3 is 6, minus 1 is 5. Denominator 3 minus 1 is 2. So I have 5 halves. 5 halves is the same as 2 1/2. So over 3 up 2 1/2. So I'm looking at another branch up in this section. Okay. Questions about that? Okay. Sometimes they will ask you for the domain. We did list it earlier. If it doesn't ask for it, I'm not going to require that you put it down. But that domain does lead to your vertical asymptotes and your holes. So we do kind of find it regardless. All right. Our next example. What would we get if we factored it? Good. So I have domain issues where? A negative 3 and positive 3? Can I get rid of either of those factors? All right, so we have vertical asymptotes at negative 3 and at positive 3. What about horizontal asymptote? What can you tell me? Top degree is smaller, right? Degree on top is 0, degree on the bottom is 2. So when the top is smaller, we have a horizontal at, all right, make sure you put it as an equation, y equals 0. Now, we have broken our coordinate plane into 6 little chunks. Okay? We have to find enough points that we know if there are pieces in each of those little chunks. Now, before we start, could I have a branch up here and a branch down there? I'm being told that I have a function here, right? F of x. It's supposed to be a function. If I have a branch in the 2 quadrants or the 2 little pieces where I put that x, would it pass the vertical line test? No. Okay? So you're going to have a branch in one of those 2 spots. You're going to have a branch in one of these 2 spots. Does that make sense? And something over here in one of them, but not both. Okay? So what we're going to have to do is find some points in each of those little sections to help us figure out where our graph is located. Okay? So we're going to start out finding intercepts. And then we'll go from there. What happens when I try to put a 0 in for x? What do I have left over? 2 over negative 9. 2 divided by negative 9 would be negative 2/9. Okay. What if I try to put a 0 in for y? Remember we said to find that x-intercept, I need to figure out what makes the top 0? Can this numerator ever be 0? No. So we don't have any. Okay, so we have a y-intercept here, but no x-intercepts. Okay, so I'm crossing the y-axis at 0, negative 2/9. So I'm just below the x-axis there. And since I know I don't have any x-intercepts, I'm never going to cross that horizontal line. I can predict that there's a branch down in this bottom middle section. Does that make sense? Probably kind of an upside down U-shaped looking thing because it has to approach the 2 vertical asymptotes. Let's find a couple more points. So let's do negative 2 and positive 2. Will I get different y values when I plug a negative 2 in versus a positive 2 for this particular problem? No, because I'm squaring that, right? The x is getting squared. So putting a negative 2 or a positive 2 in there is going to turn this into a 4, right? 4 minus 9 is negative 5. So I have negative 2/5. Okay. All right, so I am looking at a branch in this section. It should be completely underneath the x-axis, so let me try to move this here. Okay. It is not completely flat on the top. It is curving a little bit, but it's very slight. Okay. All right, now we need to find a couple other points. So we need to go on the outsides of our vertical asymptotes. Let's use 4 and negative 4. Okay. What are we going to get with a 4 or a negative 4? When we square it, we get 16. 16 minus the 9 is 7. I end up with 2/7. Okay. Yes, no? All right, so at positive 4, I'm up at 2/7. And at negative 4, same thing. So we're looking at branches here. Now, if this was a test question, I would expect to see all the work that I've just shown. What are the vertical asymptotes? What are the holes if there are any? What are the horizontal asymptote? X and Y intercepts and extra points used to graph it. Okay? Your graphs should be showing me that you are approaching those asymptotes without touching them. The vertical ones especially, you are never going to cross a vertical asymptote. Ever, ever, ever. Okay? Can't happen. Creates a 0 in the denominator. Doesn't work. Sometimes we had a few examples when we did that Desmos activity where we crossed through a horizontal asymptote near the origin. But remember, the horizontal asymptote is there to help you know what it's doing on the far left and right, not near the origin. Okay? So make sure your graphs are approaching those. My board, as always, is off a little bit, so it's not getting as close to those asymptotes as it should be. But on your papers, I would expect to see that. Okay? You want it approaching them without crossing those vertical ones. Okay? All right, next example. Let's get the denominator factored. What would we get? X squared minus 2x minus 8. What does it factor into? Okay. So, what are my domain restrictions? X can't be a negative 2 and a positive 4? Okay. Can either of those factors be reduced out? All right, so there's no holes. We would have a vertical asymptote at x being 4 and at x being negative 2. All right, go ahead and draw those in. Horizontal asymptote. Top degree is smaller than the bottom degree, which means we have one at 0. Okay. X and Y intercepts. All right, so what do we get if we put a 0 in for x? All of my x pieces go away. I have a negative 3 divided by a negative 8. Negative negative would be positive, so 3/8. Okay, so I'm crossing the y-axis at 3/8. X-intercept is what I get for x when I put a 0 in for y, which really means we're just looking at the numerator, right? Because 0 times the denominator is still going to be 0. What makes the numerator 0? A 3? All right. Based on those 2 points, the y-intercept is showing me that I am just a little bit above the x-axis, but the x-intercept is saying I do cross through the x-axis at 3. Knowing where my vertical asymptotes are, I can expect that I have some kind of graph coming down like this, hitting that y-intercept, coming around and crossing through the x-axis at the x-intercept. Okay? Which means we need to figure out what's happening on the outsides of those vertical asymptotes. Let's choose a 5, something just to the right of our positive one here. And let's use negative 3 on the other side. Okay? You can put those values into the original problem or into its factored version. It doesn't matter. If I put a 5 in the factored version, okay, top is 5 minus 3 or 2. So numerator is 2. Denominator, I have 5 minus 4, so a 1. And 5 plus 2 is a 7. 1 times 7 is 7. So I'm at 2/7 when x is 5. So just a little bit above the x-axis. If I put a negative 3 in, all right, numerator is negative 3 minus 3. Negative 6, denominator. Negative 3 minus 4 would be negative 7. Negative 3 plus 2 would be negative 1. Negative 7 times negative 1 is positive 7. So at negative 3, I'm just almost to negative 1. Okay? So I can expect that there is a branch down here and one up here. Come on. All right. The last thing we're going to look at is what happens when we have a slant asymptote. Do you remember the situation that would create a slant asymptote? The top degree, the degree of the numerator, is 1 higher than the denominator's degree. Okay? So a slant asymptote is just a slanted line. So instead of being vertical or horizontal, it's at a slant. It only shows up if the degree of the numerator is 1 more than the degree of the denominator. We can find the equation for that asymptote, for that slanted line, using division. Long division, synthetic division, depends on what our denominator is. All right, before we get to our first example of this, when we did long division or synthetic division, we often got an expression like 2x plus 5, and then we had that little remainder piece. So let's say we had 2 divided by x minus 1 as the remainder part. Okay? Now my question for you is, as x gets really, really large, okay? So as x goes towards positive infinity, meaning a really large positive number, or negative infinity, a really large negative number, is subtracting 1 from it going to change it much? In other words, is there a lot of difference between negative 101 million versus just negative 1 million? No. If I take 2 and divide it by a really, really, really large number, what happens to it? It gets really small. Yes? So picture 2 being divided by infinity, right? This huge number. It's going to be so tiny that the remainder part isn't going to matter. Okay? It's going to be so small it's not going to have any influence on it. So when we look for that slanted asymptote, we are just looking for that front piece. Does that make sense? And if the degree on top is exactly 1 higher than the degree on the bottom, when you take an x squared divided by an x, you're going to get an x. Yes? So you're always going to get just a linear expression. Ignore the remainder piece. Okay, so we said we could do this synthetically or with long division. Can this first one be done synthetically? Yes? We're dividing by x minus 1, a nice linear expression. Okay, so let's set it up. If we're dividing by x minus 1, what goes out front? A positive 1. Are we missing any terms in the numerator? We don't have any x's. Okay, so when we write our coefficients, we have 1 for our x squareds, we have no x's, and then our constant is 1. Okay. Go ahead and bring your first one down to get started. We multiply. 1 times 1 is 1. And then we add our column. Repeat it. 1 times 1 is 1. Adding the column gets us a 2. That 2 is what? That's the remainder. So again, ignore the 2. Okay? We don't have to worry about the remainder. What's the other piece that's left over? An x plus 1. All right, so our slant asymptote is y equals 1x plus 1. Okay? Do we have a horizontal asymptote? This should be an easy one to answer, because if we have a slant asymptote, can we have a horizontal? No. Right? The slant asymptote occurs when the top degree is bigger. We said there's no horizontal asymptote for that. Okay? Vertical asymptotes. Do we have any domain restrictions? X can't be 1, so we have a vertical asymptote at x being 1. All right, so let's fill that information in. Vertical asymptote at x equals 1. Our slant asymptote is that line y equals x plus 1. Okay, so we have a slope of 1, y-intercept of 1. Okay, so I'm starting at y being 1. I'm going to do a line that has a slope of 1. My board's off here. All right, so we have that slanted asymptote. Let's find any intercepts. The x-intercept is the value for x when y is 0. Y-intercept is the value for y when x is 0. All right, so what do we know? If we put a 0 in for the y, okay, we're looking for what makes the top 0. Can x squared plus 1 ever be 0? No. Okay. So I'd say there's no x-intercepts. Y-intercept, if I put a 0 in for all of my little x's, what do I have left over? 1 divided by negative 1? All right, so I have a y-intercept at negative 1. All right, let's fill in a couple more points. Let's take something to the right of x being 1. Let's say 2. What do we get if we plug a 2 in? 2 squared is 4. 4 plus 1 is 5. Denominator, 2 minus 1 is 1. 5 divided by 1 is 5. So I have the point 2, 5. Okay, now you can plot some more points. When you have a slant asymptote like this, there are 2 typical graphs that you're going to see. Okay, one of them has the branches inside the 2 asymptotes. So for this picture, knowing where my 2 red dots are, I can expect that I have a branch coming down here somewhere and one up in here. Does that make sense? That's a very typical graph to see when you have a slant asymptote. All right, our last one. Go ahead and factor the numerator. What do we get for factors? 2x squared is going to have to be 2x times x. How do we get the 5? Okay. I heard 2x minus 5 and x minus 1. Multiplies to be positive 5, adds up to negative 7 in the middle. Okay. So, does my x minus 2 in the denominator cancel with anything? Which means it is a, what does it give us? A vertical asymptote. Okay. So we know we have a vertical asymptote at x being 2. Do we have a horizontal asymptote? Do we have a slant asymptote? Yes. Top degree is exactly 1 higher than the bottom degree. So we're going to take that 2x squared minus 7x plus 5 and divide it by x minus 2. Can we do that synthetically? Okay. We have a 2, a negative 7, and a 5 for our coefficients in the numerator. What goes out front? A 2. All right. Doing our synthetic process. We bring down our first 2. We multiply them to get 4. We add. Multiply again gives us negative 6, and adding gives us a negative 1. That negative 1 is remainder. Do we worry about the remainder? No. What expression or what linear equation am I going to write for my slant asymptote? And give me an equation. It's a line, right? Y equals 2x minus 3. Okay. Go ahead and graph the vertical asymptote and the slant asymptote. Okay, and let's look for our intercepts. All right. What's going to make the top 0? It's quadratic, right? 2x squared minus 7x plus 5. We could always go to the quadratic formula, but we have it factored, so can we find the zeros from our factors? What makes this 2x minus 5 equal to 0? 5 halves. Okay, and what makes the other one? All right, so we have 2x intercepts. One of them is at 5 halves, or 2.5. And one of them is at 1. Okay. Let's find 2 other points. Oh, sorry, we need the y-intercept. Y-intercept, if we put a 0 in for all of our x's, we end up with negative 5 halves. Okay. Now, I said there were 2 basic pictures that you can expect to see with slant asymptotes. One of them is like the one we did just a minute ago, okay, where the 2 little branches are inside the asymptotes. This one has the branches on the outside of the asymptotes. So based on my x and y intercepts here, I am expecting a branch to come down here. Okay? And then I am expecting a branch over here. That's another typical graph. Use more points, extend your t-chart, and find some other points if you're not sure. Okay? Questions? All right, I will get you guys some graph paper. I do expect to see all of this work shown on your homework.